All right, yeah. So I'm Anthony. I'm currently a student at the University of Michigan. I just have a couple FAANG intern processes right now, and I just want to see where I'm at.
Okay, cool. Yeah, was your friend actually at University of Michigan? Because I think I did a mock with someone from there as well.
Yeah, yeah.
Okay, makes sense. Okay, so the first question is you're gonna be given a binary tree root.
Okay.
So and I want you to determine if it's a valid BST.
Okay.
So for example, a tree like this will be, and then a tree like this will not be.
Okay. Um, okay. So yeah, I'm going to run through this example first just to gain some intuition. So um, in a BST, all of its children are going to be less in the left side, and then on the right side of the node, it's going to be greater than. Um, so first, I'd like to gather some constraints. Um, can the root be null?
Yes.
The root can be null. Um, and then I guess this matters less, but what would the range of the values for the nodes be? Like,
I don't think it matters. So
okay,
you can assume they
okay,
can fit. You can assume they can fit
okay,
into an integer.
okay. Um, okay. So, um, okay. So I'm thinking at a high level that we're going to want to do some sort of DFS. Um, so how this how this would work is I would first determine if the current node is going to be in a correct range or not. So first, like determine if node is if the node's value is in the correct range,
Mm-hmm.
and then if this is true, then I would just recurse left and right. And so left recurse to right recurse, and then with this, yeah, and then this function would probably like return a bool. Um, so basically, like we're gonna process if the current node's value is correct. If it is, then we're gonna check the left and right subtrees. But in a BST, we're probably going to also have to pass some sort of additional information as well. So with that, maybe I'll need some sort of lower upper bound in this DFS call as well. Lower and upper bound to accurately determine the node's value. And then for this, the time would be O of n because at worst we would have to traverse through the entire graph or an entire tree. And then the space would be O of h, where h is the height of the tree. But this, if it's a leaf node, if it's like a branch, a worst case would be O of n because yeah, each node is going to be like the height of the tree is going to be the same as the number of nodes. Does this sound like a correct approach?
Yeah, I think so. Basically, you're gonna go through, like, you're gonna do a DFS for every node. You're gonna check if it's in the range, and if it is, you're gonna recurse on both ways. So essentially, you're gonna check if every node is like in the right range, and then if it is, then you'll return true, basically.
Yeah.
Okay,
Right.
yeah, I think it makes sense. I think you can code it.
Okay. So valid BST. So this would be the function, and then we would need some sort of root. Oh wait, actually, I'd like to also like clarify what exactly the class node would look like. So would it? So if,
Yeah.
I'm
So.
assuming it would have like a val,
Mhm.
and then I don't know, a left and then a right, right? Like that's
Yeah.
what the node. Okay, so this would probably return like a. I mean, this is like a node class, and then yeah, and then let's see. All right. I mean, that's all we're given for the actual function. I would just do some sort of DFS helper function that takes in a node, lower, upper, and then returns a bool. So yeah, so we're given the constraint that the root can be a null, and in this case, if not node, then we just return true because trivially like a node that is empty or doesn't have a value is going to be a valid BST. All right, and then I'm going to go on to determine if the node's value is in the correct range or not. So what this might look like is if not lower, less than, less than upper, this might look like if that's not true, then we just return false, and we won't need to execute the rest of the recursion. Else we have to check the left and right. So we're going to just pass the left, and we're going to check the left subtree, and then for the lower bound of the left subtree, there's really no constraint, so we can just pass lower again. But for the upper bound, it's going to be the node's value because we want the subtree to basically only contain values less than the current one. And then something similar for the right one is going to be passing the lower bound as the node's current value, and then maintaining that same upper bound. And then we're just going to return left and right because we need both of them to be true if it's true. All right, so now we have to call this DFS function. So it's just root and then negative infinity and positive infinity. We have to import like math, and then like math that in. And then yeah, just return that function. So yeah, that's basically what I think the solution would be. I'm gonna run through a couple of test cases.
Yeah, sure.
And see if it's correct or not. So okay, yeah, so we'll try this one first. So we have, okay, so we're going to call our function DFS root, which is going to be 2 with like negative inf, positive inf. And then in this call, it's going to basically check if the node's current value is less than or equal. I mean, it's going to check if this is correct or not. It's not going to return false here because it's valid. And then we're going to recurse left and right. So we're going to call another DFS here for left, and it's going to take in 1, lower, up, lower, and then the current node's value. And that's going to call this new DFS function here. And then we're basically going to keep recursing. It's going to basically be correct. It's going to go to its 2 like leaf. Because it's a leaf node, it's going to return true on both its left and right. So this is going to, so after we call this function, it's going to return true on the left. And then we're going to recurse on the right subtree as well, which is going to be like on this. And then it's also going to basically be correct. Both of their leaf, both of their like children are going to be null, so it's also going to return true. And then ultimately, this function is just going to return true because both left and right evaluates true. Okay, and then sorry about that. So now I'm going to do the invalid test case.
Okay.
Wait. Yeah. So basically, we're going to recurse left. So it's going to be this. It's going to recurse left, and all the left is going to return false because when we do DFS of 2, it's just this first if statement catches as invalid, so it's going to return false. And then we're going to recurse right, but it just won't matter. And it's going to return false.
Okay.
Yeah, that's basically. I mean, I could. Okay, I'll also go through like just the null case as well. So basically, like if we just had like a, I don't know how to represent this, but it would be like a none.
Mhm.
We'll just call DFS none with like the boundary lower upper, and then it's going to just return the base case. So that's just true. Yeah, that's basically first. Yeah, this is basically what I think.
Yeah, I think this is good. I think we can move on.
All right.
Okay. So second problem, you're given a string S.
All right.
So S like this. And you're given an array of words. So like this. Okay. So
Okay.
basically I want you to return the number of ways I can split S into words in words. So in this case, it would be
Okay.
1 because I can split like this. And then if the words instead were like if it was the same thing,
Number of
so, or just this. Then this would be 0 because there's no way to split it at all.
All right. Okay, so I'm just going to run through this first. So this words array is going to have 2 strings, leet and code, and then when return the number of ways you can split. Where's okay? This is S LeetCode into the words in here. Do we have to use all the words in this array?
You don't have to use all the words. You don't have to use any words, and you can reuse words.
Okay. 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 So okay, I'm gonna write that down. So basically we can use any or no words at all. We can also repeat the words and repeated word in words. And then basically the string can be empty as well. S can be empty. Okay. Okay, so the first thing that comes to mind for doing this is doing some sort of recursive solution. Basically like having like oh wait, actually no, I should run through the example first. Okay, so in this example here, S is equal to LeetCode. We have a words array, leet and code, and then return the number of ways I can split S. Okay. Okay, so it's not as simple as just if we have to find the number of ways. All right. Okay, so basically we have one way to do it because we have leet and we have code. So that would just be one way. And then in the second example, we have LeetCode, but the words are just leet and then co. That would be 0. Okay. Okay. Thinking of doing some sort of DFS solution, but this might not be optimal. So basically, I would just have a good DFS with an index of the current string, and then basically, like if we reach the end, if the index is equal to like the length of the string, then that's like one valid way. That's like one valid way to actually do it. But yeah, and then if that's not true, then we're gonna have to basically like test certain substrings, like some sort of like for loop, with like maybe like a secondary index counter thing to test different substrings, and then like for j in like I to the end, where n is like n is equal to length of string. Probably just like try different subarrays, I mean substrings. If it's in the like word, I would make words a set. So like for O1, if it is, then we just recurse for like the index onwards, if J is like the end of the substring, like something like this, like recurs onwards. And then this is going to return a number. Would it make sense for this to return an integer?
Yeah.
Okay. Okay, and this will just return like everything, and then else we should return like yeah. We don't want to return, but we would have like some sort of counter. Count 0 to 0 or something, like count equals return count. Think it would work something like this. Maybe like some sort of caching as well might be useful. But I'm thinking can't think of the time or space. Let's see. So if n is the length of the string, and we're trying like many different subarrays, substrings. I feel like this is like an n squared solution. If like where n is like the length of the string, and then this might also just be n as well, like for the space. Does this solution make sense at all?
Yeah, so I think it makes sense. So if you have caching, I think it makes sense that it's going to be n squared because I can be 0 through n, right? And then you're looping through the whole string. So let's think about some optimizations we can make. How can we reduce? So I think worst case, it will still be this, but on the average case, it's going to be a lot better. So are there something, because right now we're basically just like looking through the string and checking if the whole thing is in there. And we keep building. Actually, I don't think this is even n squared. I think this is n cubed because you're building the word every time too, right? Like here, this is n cubed. So we can definitely get a complexity benefit. So let's ask one thing first. So let's focus on this thing. So right now, basically what we're doing is we're like let's say our string is like LeetCode, right? And we start here. Like we have to basically build L and then LE and then LET and so on, right? And each one of these is like an O-of-N operation. Is there any data structure we can use to not have to like build these strings and to also have pretty good like pruning where we like let's say once we get here, there's like nothing left in our words. We don't have to keep checking the rest of the string.
Like a try? Would that be like over-engineering though, or?
No, I don't think so. So what are the benefits of the try here if we use a try?
Oh yeah, if we use a try, basically like if it just doesn't have any children, we just stop. Okay, so all right. Okay, so maybe I'll make like another solution which use like a try, and then let's see. So I would definitely need like a constructor with stuff. Constructor, and then that makes sense. And then stuff in here, and then I'm going to need like a add word, perhaps, and then like a search word, perhaps. Ooh. And then maybe perhaps this like search word would be used like in here.
Okay. And so if we have a try, I mean, you don't have to code up the exact functions. Like then what would be our time complexity now with the try? So I think right now, it used to be n cubed, I think.
Yeah. Okay. Yeah. With the search word, probably like n squared log n.
So where do you get the
Um,
log from?
I mean, I'm not too well versed in the theory, but I think it's like the search word would be like it reduces it down quite a bit. So I'm assuming the search word would be log n.
So for a trie, so do you know how like a trie, like how characters are stored in a trie, like how it works?
Yeah, so we have like the so each node, each like trie node has like its children. So like it has like all of the next valid words that it has. Like we have instructor. It's just like a hash map with all of its like children. So
Right.
yeah. Would using a trie solution be like over-engineered in this case?
No, because it's gonna reduce complexity by quite a bit, and we have a decent amount of free time. So I just wanted to push towards this approach.
Okay.
Yeah.
Okay. Wait. Okay. I mean, I'm not too well versed on like the theory, but I'm assuming it's like log n for search, but it might be like even quicker. I don't know.
So, for example, if you store a word like word,
Sure.
So here, like, so the level, like the top is like the root of the trie, right?
Yeah.
And then if you just store word, it will basically go like this. So each one of these will be a new node. So it'll be like WORD, right? Something like that. And each one of these is a new node. So here we'll have like 5 total nodes. Does that make sense? Yeah. And so if I'm searching through a word like word, I start at the root, and then as I process another letter, I would go into another node. So like here, I'd be here, and I'd start at the root, and then as I like check for the W, I'll say like, oh, is W in here? Okay, it is. So I'll move down here.
Okay.
So you're basically like traversing both at the same time. So it's not really log; it's like linear.
Okay.
So and then also, yeah, what you mentioned is like if I'm searching through Word and the W doesn't exist, now I don't have to do like any of that stuff. So it actually cut down to n squared because you're just like traversing both at the same time.
Oh, okay. Okay.
Okay, so let's try to, so does this make sense basically? So what you're doing is like you are adding all the words into the trie, and as you're searching through the string, you start at the root, and then you just traverse down your nodes as you traverse through the word, and you just keep checking. So by the way, for a trie, how do you know, like, are you familiar with like let's say I'm on this node. How do I know that this is a word or not?
You could have like each node stores like is a word or something, which denotes like it's like the end of the word.
Right, and so basically whenever you have a word, you can just like recurse. Because you know that's like a valid split.
Okay. All right, I could try coding it up. We'll see.
Yeah, sure.
So yeah, so first we have to define the trie class and the trie nodes. So yeah, like something like is word would denote the end of a word. And then we're gonna need like the root of the trie. Yeah, okay. And then this is gonna be word. I'm gonna do search word as well. Oh, okay, wait, and then wait, could you go up to the pseudocode again?
Yeah.
Like around here. So basically we're just calling this like trie function basically to try the German substrings, right? And then we'll just do like this, the recursion onwards. Like this.
So I don't think you even need, so you can think of a trie kind of like a tree. Like, so typically you can just have it all in one class. Like a tree has one class, right? It doesn't have like a tree root and then tree node. So trie is like the same thing, except basically the only difference between a trie and a tree is trie has more than 2 children, or it can, but the rest is the same. So you're basically just like when you are going through the word, you want to start at the root of the tree, and then you just want to check like is car in trie. If yes, recurse. If not, then stop.
Oh, okay.
So I think you like so I don't think you even need the search
thing.
Okay.
We yeah, okay, yeah, you're right. Okay, so we can just yes, after we add a word, we just do some sort of like get count, get number of ways or something. I'll just take in our string for now. Okay. Okay. So we would have to. Okay. Wait. So the question is return number of ways I can split S into words. So return number split string or something, and then it takes in S words, and then okay. I'm gonna first start by just doing like the high level without coding up the try. So first we would have to like initiate the try, and then we would have to, for every word in words, maybe make it a set just in case there's like duplicates or something.
Sure.
Just do like t.add word
Okay.
w, and then I'm assuming this try get num ways would just return an int. So I'll just return like t.get num ways of the string.
Okay.
Yeah, does that
so
sound...
basically you're gonna write so you mentioned in your pseudocode you're gonna have like a DFS or DP function, so that'll be this get
Sure.
num ways. That's what you're saying?
Yeah. Does that make sense?
I mean, you can do it that way. That's fine.
Okay.
You can write it in like a bunch of different ways as long as like you have the info you need. You can write it any way you want. Yeah.
And then I would also need I would also need like a search word, right, to do the find the word in the...
I mean, it depends how you write it. Like, I don't really know for sure, but
okay.
Yeah.
Okay. Yeah, we'll see. Okay. So this like high level is basically how we would do it, right? Like So first in this self dot. Okay. So the current is equal to self dot root, and then we're just going to iterate for each character in the word. Dot. No, if the current character is not in dot children, then we're going to want to basically just create like a new try node, and then
because the way you wrote it here isn't correct.
Oh, okay. Yeah. And then we do cur is equal to cur dot children to iterate through each thing, each try node. Well, okay. And then one thing at the end, because we've like reached the end of the word, we're also gonna have to mark this word to be true as well. Okay. This is where like it's the meat of the function. Let's see. Okay, so just to like gain some like intuition, basically we have like this add word thing that like our try basically just stores like a lot of different like words and like paths to the words. And then we're basically going to use that to reduce like the time it takes to basically traverse through and find if it's like a valid word or not. All right, so first I would need like some sort of counter to count how much ways we can actually split up the word. And then probably have like a local DFS function in here as well, like a non-local count. And then, I mean, yeah, I'll just do it this way. Okay. Let's see. There's like a lot of things to do, so I'm just gonna compartmentalize and just see if I can get it correct. So, basically, we have like the index. If the base case is just going to be if the index is equal to the length of the string, we're just going to return 1. We just do complex equals 1 return because not local. Okay, and then after this, we're going to want to do some sort of like recursion first, some way. So basically, for So J is going to act as like some sort of right bound for our substring. Oh, probably like what would that be? That is the word. What? Oh, that's an issue. Okay. All right. Wait, what are these errors? Words is not defined. Wait, it's just okay. That's fine. It's just like this stuff here. Okay. Okay. And then wait. Actually, we probably don't want to use that, which is it's better if our DFS just returns an integer. So let's return 1 here. And then let's see, in this for J word. J. That word. Probably need some sort of helper function. It's getting a bit dense. Okay, so if ours go to self.root, for each character in the word, if the character is not in children, children, we return false. Children, ch, turn true. Does this search word make sense to use?
So the search word makes sense, but I don't think you can actually use it because, like, let's say I have this and I have some random try. Like, ideally, basically, I can't just say like is leet in my try now is leet C in my try because then you're restarting the entire search. You want to maintain what node you were at before, so that way when you add one more character, you only have to go down one more node. So the whole thing is linear. If you did search word on every index, it would be unsquared.
Okay. Wait, could you keep that there actually?
Yeah. So basically, imagine I call search word on leet, right? I check is leet in my thing.
Okay.
Now I add another character and call search word again. I'm basically starting all over.
Yeah.
But why would I start all over? If I knew leet was in there, I'd be at some try node, right? I'd be at some try node here. And then all I have to do is just check, is this thing in that try node's children? And then just, that's like a one operation. Does that make sense?
Wait, so I understand like the repeated work of like basically keeping a pointer so that we don't have to re-look at like leet versus like Lee. But I don't quite understand how I could use that in this question.
Yeah, so basically in your DFS, you can just start at the root. So you can say like, in the DFS, I'm at the root.
Okay.
And then is L in my root? If it is, I'll go to that child and then keep going that way, right?
Okay.
So every time you do a DFS, you always start at the root.
Okay, I see.
And then that way you're basically traversing your try at the same speed as you are the other part. Yeah.
Okay, I see. So, but it's kind of hard to wrap my head around like traversing through and also like maintaining the count as well. Like maintaining like the total number of ways we can split the word as well.
Well, basically, it's like you said, right? Anytime your try tells you it's a word, you can just recurse and add to the count, and then you just keep going.
Okay.
Yeah.
So for okay, that makes sense. So for every word in string, we're gonna basically just check to see if okay, so we do want to recurse through each of the tries. does okay for j in range of I plus 1 to n. Let's see, like, so the current character is going to be word j, and then if ch in return prize children, let's do cur is equal to cur dot children ch. Okay, I'm gonna need like cur is equal to self dot this cur is unbound.
So you need to reset it every time you call DFS, because every DFS call needs to start at the root of the trie, if that makes sense. Because like, let's say I have leet in code, right? And I say, okay,
Right.
I can admit this is a valid split. Now when I look through code, that needs to start at the top again, not where leet ended off. Does that make sense?
I don't quite get that, because I thought the whole point of the traversal was to save the progress of like the.
So you save
Of,
the
like, where we were.
progress. You save the progress as you're going through like one chunk. But when you go to the next chunk, you need to start over, because essentially when you split LeetCode into leet and code, you're checking is leet in my words and is code in my words. So every time I do a split, when I start looking through it again, I need to start again.
Oh, I see.
But as I go through it, then I save the progress.
Okay. I see.
Yeah.
All right. Okay, so we don't want to actually initialize that up here. Initialize that in here for each DFS call. And then, so, okay. And then if her dot is word, then we can do some sort of DFS. Yeah, 1 plus equals DFS of j plus 1. Yeah, and then so if else, we can also just like stop this df. Else continue or return. Let's see. So for this index, oh, it's definitely return.
Yeah.
Else, okay. This is not like eloquent. Else we need to like return 0 for this DFS path. Does that make sense?
So does returning 0 make sense?
Oh, okay. Turn 0 1. Oh, okay. Okay. Because we've maintained like a count. We probably don't want to zero out all the work we've done so far.
Right.
Okay. Okay, this is not like very eloquent. And then yeah, if it is a word, we're gonna recurse j plus 1. And then okay, and then we would just turn DFS of 0 here for if this is everything. See, does this make sense? Yeah, so we're basically recursing through, I mean, not recursing, but we're traversing through the entire each character in the word. And then if it is correct, then we're gonna basically increment cur. Else we're just gonna return the amount we've accrued so far. And then with this is word, we're basically if it is correct, we're gonna start like a new DFS. Like for example, if it's like LeetCode or something. Like and then our words has like LeetCode. It's probably going to if we find that it is a word, we're gonna like start a new DFS. At j plus 1 would be 0 1 2 3 4. But as you mentioned, we're gonna like return back at the root to basically see if code is in here as well. Yeah, so this does make sense, I think, but yeah.
So I have a question for you. So here,
Okay.
you can get, like the way you have it, you don't have caching, so you can get to this state a bunch of times. So can you improve that?
Okay. Yeah. If we want to do, is it wrong to just do like the LRU cache and just like
I mean, you
that
can,
not?
but I want to see if you can write it correctly. So I'm just gonna say you
Okay.
can't do that.
Okay. Um, would it be better to do like a cache in the actual like constructor, like a self.cache, or would it be better just do it for get like in the get num ways? Would you say?
I mean, that's whatever works. Like, I don't really have a
Okay.
personal preference.
Okay, I'm just gonna do it in here. So I'll just do cache. Oh wait, so wait. So how exactly like would a cache actually help here though? Is like my question.
Sure. So
It's,
let's say we have an extreme case of this,
okay.
and our words might be like A and then like
Mm,
AA and whatever. So we're gonna
okay.
get to the same place like a bunch of times because like you can split it this
Okay.
way or you can split it this way or whatever. And so
Okay.
ideally, if we've been to some spot, like let's say here, and we know like from here, this is 5 or whatever, we just want to return 5. We don't want to keep doing the thing over and over and over and over.
Okay. 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 All right. So basically, if hmm, I feel like caching in this problem is like might be harder than just like would it be harder than just regular caching? Because like maybe not. Okay, I'm just gonna try like the regular stuff. So it's like if I is in cache, we just return like cache I,
Mhm.
and then okay, and then basically pretty sure just down here we could just do like after we've done everything, we just do cache I is equal to count.
Mhm.
I don't think we do anything for the recursive stuff. Like we don't want to cache in the recursion. Probably just something like this.
Yeah, I think yeah,
Okay.
there's not really any extra stuff you need. So
Okay. All right. I'll run through an example, I guess.
sure.
Okay. So, all right. Let's just do the. All right. Let's just do like the. All right. Let's just do the first one.
Okay.
So here we have s is equal to LeetCode, words is equal to leet, and code. I don't know how I'm going to represent this like try like structure. It's,
You can draw it like a tree.
okay. 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 So this is like how do I even like this is the root, and then it has like the. So it's gonna have add word leet. So it's gonna have like one here. Why is it doing that?
Mhm.
Like a LC, and then I mean I'm just gonna do it for every word. I don't really. Yeah,
That's
whatever.
fine.
And then
Yeah.
why is it doing,
So why don't you
yeah
do,
yeah
instead of that example, add this to the example? If we have also this.
okay. Okay, that would be the example as well then. We'll have something like this anyway,
Mhm.
with like the D and then leads, and then this is like, and then this is gonna have like the like this China would have like a is word or something.
Right.
Okay, it's like one sec. I don't know how to get the I don't know how to like symbolize this in the
Yeah, it's kind of annoying. It's fine. I was gonna say you
um
can just add like a star or something if it's a word, something
okay,
easier.
okay, yeah. Okay, yeah, that's better to do actually. Whatever it's so that like it would have something like this. Is word. I mean, okay, yeah, like is word is like true in this case.
Sure.
Um yeah, so that would be what we do when we like do this for W and like add each word.
Mhm.
and then okay, and then we would call like get numways after. So this might be a bit heavy. All right. So we're gonna call DFS. We're gonna call so get numways of string is going to be LeetCode.
Mhm.
Okay. Okay. So okay, and is going to be 3, 4, 5, 6, 8. How can I like dry run it like quicker? You know what I mean? I feel like I'm doing this like really slow.
Yeah,
Like
I
I
mean,
don't.
you can just call DFS. You can say like DFS add a value and then show the recursion stack, and that's good enough, I think. So you
Okay.
could say like DFS 0, DFS wherever it DFS is, and
Okay.
then yeah.
Okay. So DFS 0. It's gonna basically skip the caching. And then count is equal to 0 here for each character in the word J from word J. Ooh. The issue with this for J in range I+1 is that it's like skipping the first like letter.
Mm-hmm.
Might be better just to do this. Let me see. It's skipping the first letter of each in LeetCode. Yeah, it's probably better to do that. Yeah, and then we're basically gonna call DFS 0. Okay, for each word, we're gonna basically recurse through the trie, and then we're gonna see that leet is a word. So we're gonna call DFS of J plus 1. So what that's gonna look like is 1 0 1, wait 0 1 2 3 4. Oh, it's 4. Yeah. So we're on DFS 4 now, and then let's see. Okay, so like in a way, our string is like the remaining string would be like code. In a way.
Mm-hmm.
And then we're gonna come across this CO first. So we're gonna have to do, what is it? 0 1 2 3 4 5 6 7. Wait 0 1 2.
I think it's 6.
6. Yeah, so we're gonna come across like this CO first.
Mm-hmm.
Let's see, come across this CO first. So like in a way, S is going to be DE left. And Y is okay. And then it's gonna call DFS of wait. It's gonna keep going. And then okay. It's okay, it's gonna keep going and then it's gonna go to DE. And then it's gonna say it is a word. But J plus 1 is going to be, yeah, that makes sense. I think that looks correct. It's gonna call like DFS of like probably 8, and then it's gonna return 1.
Mm-hmm.
Yeah. Yeah. And then we're gonna go back from here, like unwind until we get to like this state again. And it's going to do, we're basically gonna find like the other one with just code. Is that correct? Ooh. Okay, looks to be a bug in here. Wait. Okay. Wait, just to clarify, isn't there like an issue with there's an issue with let's see. There seems to be an issue with okay, wait. So So if I unwind the DFS, we're back at DFS 4. But the issue is, like, we kind of already recursed into the CO.
Yeah, so it'd basically be like back here now, right?
Yeah, so
here.
oh. Okay, wait. So isn't there like an issue with like the way it's like duplicated right now? Like it's gonna keep recursing when it comes across is word. But I wouldn't really know how to like prune like duplicates.
So what's
Like-
the duplicate you run into?
It's gonna keep going to like when it returns back DFS 4, it's gonna see like CO is like CO is the end of the word. And it's gonna keep like recursing through this, like probably gonna be like infinite loop. I don't know, something like that. That's what I think. No?
So okay, so in your code, so basically you would go like when you get to the CO, right? You would go to this line 155, 156. Then it would say is word is true, so you would recurse. Then you would come back, and then you would look at the next character, and then you would go to the next try. So you wouldn't recurse down the same path twice. Because if this is true, you would just still go to the next part of the loop. So it wouldn't be like an infinite loop.
Wait, sorry, could you say that again?
Yeah, so if 159 is true, it will recurse, right? But your cur is currently on what? Oh, here, right?
Sure.
So it'll be cur and then it will recurse.
Oh,
then it will go back
okay.
up, and then here it will go to the D. So it'll say
now
it's here, and then it's fine.
Okay, yeah. Okay, yeah, actually, yeah, that shouldn't be an issue actually.
Yeah.
Okay, yeah. Okay, actually, yeah, that's not an issue. It's gonna resume from like the CO. Okay, yeah, so yeah. Let's go down here. So like when we do like the lead and then we do like the code, it's gonna like resume from here. As if like we just skipped it. And then it's gonna call it again. Like it's gonna basically like it's gonna skip the like we just traversed through this path of like the CO path split, and then we're gonna return from the recursion, and then it's gonna find this other solution.
Yeah,
it's gonna return one, and then it's gonna sum everything and just return to total.
Yep. Okay. I think we could stop here. So what do you think you did well? What do you think you can improve in?
There's like a lot of things just like happen. I gotta like process this for a sec. Let's see. So I think I asked for like too much hints, perhaps.
Okay.
And then I think that like I was a bit like over the place sometimes with like the process in a way. Like there's like I remember I forgot to like ask for constraints. Just and then also like I messed up on the time complexity. I didn't fully understand like the try solution in a way. Yeah, and then perhaps like running the code could just be better in general. It's not something I work too much on, so.
Okay. Yeah, so I'd say the first problem was honestly I felt like you basically did everything perfectly and it was like too easy for you. Like I think you did it in like 10 minutes or whatever. It was like, okay, well, clearly I need to ask something like more difficult because like, if I do that, it's just going to be like a waste of time. So I definitely think for like the easier text screen problems, at least for my like what I've seen, you can definitely like crush those, no problem.
Wait, one question. Sorry. Yeah. So like, it's kind of like obvious I've like done this problem before. Like I feel like I was like I didn't explain it very well. Like I kind of just said, oh yeah, like we have like an upper lower. I feel like is there anything I could do to like in a way like talk about it more eloquently? I feel like
I don't think it matters because it's hard for me to tell like did you do it before or is it just an easy problem and you just like know it super well. Like because like if I got asked this problem and I haven't done it, I'd be able to figure it out like right away because it's not like algorithmically, even if you haven't seen it, it's pretty easy. So then I was like, well, I'll just give you a second one based off of how you did on the first one. And I felt like I'd just give you a harder one. And so I think for the second one, also, you figured out it was DP. Like, I mean, maybe you've done it before.
No, I haven't. I could tell it was like DP vibes, but I'm not too strong in DP. So like, I'm like, okay, like I'm better at like DFS. So I wanted to like lean more in towards like the DFS.
I mean, so top-down DP is basically DFS with a cache. Like it's the same thing.
Yeah.
So that's why it's like not very difficult. But yeah, so we had a ton of extra time. So I was just like, I'm just gonna push towards this. It'll make you uncomfortable, and then like if I need to give you hints, I'll give you hints because this is like a significantly harder, I think, than intern problem. If I make you push in the like this direction, and for what it's worth, yeah, I definitely think for the second one you weren't sure about time complexity, and people get it wrong all the time. I think you said it was like n squared, and I was like, how do you optimize? And you were like, oh, if you use a trie, is it like over engineering? Well, no, because it actually gets rid of a dimension. Like you don't have to do string compares. So so you go down from like n squared or whatever or n cubed to n squared. And I was like, are you? Well, I just want to see like I guess you've used the trie before, but maybe not super familiar. So I have to give you some hints.
I've used it, but I kind of like glossed over like the theory, like the time complexity and such.
Got it.
I've probably done like 3 or 4 maybe.
Yeah, so I think that's really good. If you were only like with the amount of hints I gave you, if you've only done 3 or 4, that's like a good sign because I would just expect most people who've done 3 or 4 to just get stuck. So you did go in like the wrong direction in some ways, and you were like, oh, it's kind of a little bit unclear in my head, like how I'm doing stuff. But I felt like it was still pretty good for an intern, and like your experience. And I pushed for like a harder solution. So then I was like, well, if I'm going to push for this harder solution, I will give you more hints and it's fine. And unless you like completely can't do anything, like it's fine. So, so I did give you a decent amount of hints, but because I pushed for a harder solution, I felt like that's reasonable.
Is the DP solution like a lot easier to code up?
Yeah. So DP, you just wouldn't use a trie, and you would just use string compare. So at every index, you would just check what you had, right? That like is my substring equal to the word in the words.
Oh, okay. I mean, yeah, I'm not too good at DP, so.
Okay. Yeah. So definitely, I would. Yeah. I mean, you were like a little bit unclear, like, oh, if I cache this like trie thing, is it going to be way harder? And I was like, not really. It's like the same exact thing. And then also, so some things you definitely need to work on is, like, well, one clear thing is don't ask people how you should structure your code. Because, like, that's too low level. That should be, like, on you to figure out something good. So you shouldn't be like, if I had a cache, should it be in, like, my init or here or here?
Okay.
That's too low level. You can definitely ask things like, like for the first one, like, oh, so for my tree, is this roughly what it looks like? Like that's fine. Like what am I allowed to have? But I would definitely not ask like, oh, should I use like this variable or that variable? Or it's just like too low level, and you're expected to know that. Yeah, you're expected to know that yourself. So I'd say for the first one, I mean, if you've done it before, you've done it before. But I basically said this was like 5 out of 5, and then I think for the second one, it was like a 3.5 out of 5 because I did give you a lot of hints, but you also were able to like get it even with the hints, and because you're not like a senior, you're like an intern. I think it's expected that you're gonna like get more help and get more like advice and whatever. Yeah. And let me see if there's anything else in particular. I think the main things are work on code structure. You said you didn't work on that a lot, and a lot of people only write stuff in LeetCode, and then when they have to go and code stuff outside of LeetCode, they're like, so can you give me the constructor? Can you give me the like functions? And it's like, can you write it yourself? Like, so definitely work on that. Make sure you are able to do that stuff. Those would be like red flags. Like if you didn't know how to write a class and you were like, oh, in LeetCode it's always given to me. Can you like copy paste it for me or whatever? But overall I'd say this was like for an intern. I'd say this is like a 4 out of 5 result. And the main things you need to work on is, if you're not familiar with like DP or trie or any advanced topics, definitely learn those. And then also work on like your coding. And definitely don't ask like, I think the other thing you asked for is like constraint size. People usually don't give those to you, right? Where it's like, you were like, how big can the values be or something? Like it's not LeetCode. I'm not going to tell you.
Okay.
So I'm just gonna give you some generic like, oh, it can fit an integer, or it's like whatever.
Okay.
Yeah. So,
All right.
but yeah, I'd say overall this was pretty good.
All right.
So yeah, if you want to schedule in the future, totally fine. And I
Okay.
can just do some like harder questions because I think you asked for like a text screen level, and yeah, I think the first one would be like probably like text screen level, and like I mean
Okay.
maybe you've done it, and I was like I felt like if I ask another question like that, we're gonna be done in like 15 minutes, and then it's like
Okay.
I might as well just ask you something harder, you know? So
I feel like I haven't done too much like hard questions though. Like I would say that like a bit stronger in the DFS, but like besides that, I'm like pretty clueless.
okay.
So
I mean, I guess also the nice thing is because you're in college, you have time to study the stuff. So, and you don't
yeah.
get asked any system design or anything. So,
Yeah. All right. Yeah.
but yeah, do you have any other questions?
No. Thank you.
Okay, cool. All
Yeah.
right, see ya.
Bye. Yeah.